What I'll be talking about is both how the community actually got to where it did today, which is a space where we kind of have maps, and the tools that the community used, which I think some of you will find it useful. A bit about myself. I represent two organizations, one which I helped co-found, which is Gramner, and Gramner is an organization that builds data visualization and analytics tools. And the other is DataMeet, which is really, I don't think can be better described than saying an email list of people. I don't think people really know who they are or what they are on this email list, but it's grown to about 3,000 people. Some of these are administrative officials. In fact, I met a person who ended up becoming an elected official, or he was an elected official and then became a member, I don't know. And we have people that are data enthusiasts, programmers, wannabe data scientists, all kinds of people. But one of the things that DataMeet happens to have nudged towards is opening up data in India, and maps are a big chunk of it. That's because there are three kinds of maps, map hierarchies in India, and none of these are open. The first is political boundaries. All of the data around which state has which parliamentary constituencies that elects people to the National Assembly, or the assembly constituencies which elects them to the state assembly, or the individual polling booths. That's the hierarchy that's there. Postal code boundaries have a very different hierarchy that's completely independent of this hierarchy. There's just no point at which they match except that the zones are approximately collections of individual states. And I mean that approximately because there's just no guarantee that a single PIN code lies within a single state, right? It's as bad as that. And then there are administrative boundaries. This is the largest administrative hierarchy that's there, that goes down to about 600,000 villages, and below that there is a further division called census blocks, which we try not to talk about because it gets really scary at that level. I will be mentioning a bit of that. The point is this: none of these, not one of these, has an official shapefile. It's actually even worse than that. But let's start with the simple stuff. Let's start with the political boundaries. See, we had a problem because in 2014, one of the tasks that Gramner was given was to cover the elections on television. So along with CNN, IBN, we said, let's put the maps of the country out there. But in order to do this, we needed the maps in the first place. I was particularly keen on this because this actually featured, among other things, my first appearance on national television. That figure you see in the red t-shirt at the back, scratching the beard, that was me. I said, okay. I quickly called home and said, look, turn on CNN IBN, you can see me on TV. But at least to make this happen, I had to get the maps. And it was painstaking because the only way in which the maps were available for quite some time were paper maps. Luckily, in 2014, for the first time, we had PDF. It was beautiful. It was actually digital, and it wasn't a scanned image. It was actually raster. So we could take these maps and convert them into SVG. And from that, manually trace these boundaries out within reasonable limits and convert them into a shapefile. And that took a good 3.5 months. But it was done. And we put it onto DataMeet. There's a site you can just do a search for DataMeet maps, and you'll see the community-created maps of India, which begin with the assembly constituencies and the parliamentary constituencies, which took many late nights. But it finally got to the point where we had maps and could start creating visuals on top of those maps. The first thing we did was to look at which were the parties that won in each of these constituencies. This is the result of the 2004 election, and it's colored based on the party that won. The system is far from bipartisan. There are many parties, but the two leading parties are the ones that you see in maroon, which is the BJP, which is currently in power, and the one in blue, which is the Congress, which was in power earlier. But this is the result of the 2004 election. From the map, you can kind of see that the party in maroon seems to be winning. That's the BJP. The only problem is that they did not win. It was the party that's in blue that was actually the winner. And the reason is that in some of these regions, like let's take Delhi, there's a whole bunch of tiny little constituencies, and you're not going to be able to see those constituencies on a map at this scale, on a choropleth. But that's where the party that won took the majority of their seats. And whereas this is a massive constituency, but the fact that it's a massive constituency doesn't give it any more than one seat. And you've seen this kind of a problem. So a choropleth, which is an alternate representation, helps a whole lot more. This is another version that we put together of the same thing, where each of those constituencies was replaced by just a point, and we moved around the points a little bit so that they wouldn't overlap. And incidentally, that also gave us the flexibility to add another dimension. Instead of being constrained by the geographic shape, we could say this circle can be sized based on anything that we want. In this case, let's use the number of voters. So that gives us a sense of the vote share. That's a pretty decent metric. So now if I look at the overall area, the maroons and the blues are kind of similar. They're not too different from each other. So this was a win because on the one hand, we actually could get data that is not constrained. We could actually get visuals that were not constrained by the geography. But on the other hand, it also solved another problem, which is that we could do this only for those years where there actually were constituency files or PDF files that we could convert. When we went back to before 2004, we just did not have the data. Meaning, as of 1951, for instance, we just about had the names of the constituencies. That's about it. You know that in this particular constituency, this party won. That's all the information that exists. But that is a starting point, because with the name, at the very least, I can get to a point that I can map. I don't know the shape, but I can get to a point. So choropleth is a double win. I don't need to know what exactly they look like. I just need to know where they are. And I can also get a better visual representation. Trouble though is geocoding is not something that the community can do pretty well. And at this point, the tooling ecosystem had to come in. Can we build a way for people who just don't understand technology to do this sort of stuff as part of their regular workflow? They're doing a whole lot of lookups in Excel to make sure that the constituencies are spelled right, that it joins with the other data set that has a list of people and so on. So we said, let's just build the whole thing in Excel, a geocoding system in Excel, which is released as open source, and that's the link where you'll find it. This contains an Excel sheet, which I'll zoom in a bit into so those at the back can see it. Let's pick an address, let's say Jacob Jarvis Center, and put in the formula, Google Geocode. That's a custom formula that's created on this sheet, and that looks it up dynamically, and says that's the latitude and the longitude. And you can do this, oh, okay. I was trying it out for a while before, but I didn't think I would have, okay. So fine, I was just hitting it too fast. So that's the location for 10 Downing Street, which seems to be very similar. Let's see. It was working outside. Let's see, DXB. Okay, that looks different. I have no idea whether it got Downing Street wrong or Jacob Javits Center wrong. And you could do the reverse also. So if I said, give me the reverse geocoding for a particular latitude and longitude, so let's say 40.7 and minus 74, let's see if that's in New York or in London. Okay, that's in Brooklyn, so that's close enough. At least it got the current location right. This is enabled by a simple piece of Visual Basic code, not just barely more than a page, which sends a request to Google, gets the response as XML, parses the XML, puts it back into Excel. It didn't take much time to write, but the value that the people got was enormous because they didn't have to go outside of the tooling ecosystem that they had. It was simple, it was readily usable. They said, okay, we can do geocoding. In fact, I'll talk a little more about the process of how we made it simple just using Excel. But what this enabled was the creation of a whole series of alternate visual representations. For example, one of the questions that ended up getting asked on TV was, tell me, which is the party that had the largest number of failures? I mean, we kind of know the popular parties, but are there parties that just lost like crazy? So it turns out that there is a party called the DDP, the Doordarshi Party. They, I should probably stop this. They started their campaign in 1984, and they fielded 97 candidates across the 500 odd possible seats that they could have, and they won in exactly 0 locations. 97 seats, 0 wins. Not so good. They didn't give up. They tried again. In 1989, 289 candidates, 0 wins. They'd spread across the country. Now, in 1991, they tried again with 321 candidates, 0 wins, and at this point, they were the largest party, the second largest party in terms of number of candidates. There was just only one other party that had more candidates than them. 3 times they didn't give up. But the best part of it is that not only were they never the winner, but they were never even the runner-up. At best, they were number 3. And that was usually in the places where there were only 3 candidates. We couldn't have figured this out or put this visualization together without the ability to just pinpoint the location of these constituencies. Another one that was equally bizarre was this state, or the state of Tamil Nadu, where the question was, where do people stand, where do a large number of candidates contest for elections? Are there like really heavily contested elections with as many as 20, 30 candidates that just fight for one seat? And that has happened. So we took this visual where the constituencies are located roughly where they should be. The color represents which party won, and the size of the constituency represents how many candidates stood for election. So there were 10 candidates that stood for election in Perambalur, whereas this is a smaller one. There were only 2 candidates in Tirukkoilur, and so on. Now, this was in 1967. Let's move on to 1971. Not much of a change. 1977, now there's a bit of a spurt. There's more candidates standing for elections. There's clearly a lot more activity, and you see that the color has changed as well. There's a new party that's coming into the equation, and they're doing a much better job. 1980, not so much of a change, but 1984 is when we start seeing some action. 90 candidates standing for a single election. But it goes on. 1989, big spurt. 1991, now we have 264 candidates and 249 candidates standing in 2 constituencies. Now, at this point, just to figure out which candidate you have to vote for, you have to flip through a few sheets, right? Just, oh, okay, no, not this one, not this one, not this one, and you hope that it's alphabetically organized. But all of this pales in comparison with the 1996 elections at Modakuruchi, where 1,033 candidates contested for the same election. And if you look at the names of these candidates, right, in fact, it wasn't organized alphabetically, so I did that and said, that's what the names look like. So if you're a Palanisamy K, right, how do you figure out which Palanisamy K you are if you want to vote for yourself? Which seems to have been a problem or confusion because there were as many as 88 candidates that got 0 votes, meaning they did not vote for themselves. All we needed was the location of the constituency and said, yes, now we can start doing this. Let's get back to the theme of making things simple. Now, it wasn't just cartograms, but we also wanted to make choropleths simple. Now, cartograms are great because I just need the location, but choropleths need the shape. And for at least some of these, we needed shape files. But the trouble is, it's not easy for the general public to manipulate shape files. So we said, let's put that into Excel as well. Let me give you a sense of how this works, and I'll show you how it's constructed using the open source library that we've released. So this is a map of, I think, one of the states, Andhra Pradesh. Well, used to be Andhra Pradesh. Now it's split into Andhra Pradesh and Telangana. Life is complex, but bear with me. Now, what you can do is pick a set of colors. I'll say I have this in, let's say, I want a shade of blue, I want a slightly lighter shade of blue, and I want an even lighter shade of blue for values ranging from 0 to 1. And then I can start filling values out here, 0, 0.5, 0.25, 0.75, put in some random values. And that colors the map just in Excel. And this takes, okay, this is not even the visual base, let's see. This workbook, sheet 1, no, not this one. Not this one. Yeah. So that's again about a page of Visual Basic that goes in there, which simply looks at what number has changed and maps the appropriate constituency. How does this get created? The code for this, well, firstly, if you wanted to download the maps, that's, well, let me start with the code first. This is the repository where you'll find it, github.com/gramner/cartogram. And this is a Python module. Let me show you how this works. Is this kind of visible near the, towards the back? If you're okay, I'll just go ahead and type, hoping that it should be fine. I could take the shape.py script and specify a topo.json file or a shape file, or right now this works, I'm going to show you on a topo.json file called, let's say, s22_pc.json, and specify an output file, which I'll call it output, and run it. What this does is uses the COM model in Excel, which just basically opens up Excel in an automated way, draws the shapefiles, it reads the shapefile, it knows the exact paths of the shapefile, it draws it in Excel, and then starts creating the Visual Basic code in that Excel file and generates a final output, which is simply in Excel with the macro embedded in it. That's all it does. Now, given any shapefile or topo.json file, you therefore have a map that, let me just open this output .xlsm, that has this table on the left hand side, and I can start coloring with random values, and hey presto, that gives me a map that's out there. What this did was allowed a set of people that had never gotten into GIS to start getting into GIS, specifically media. One of the things that the folks who use these visuals created was, let's go. This was one of the maps that appeared in a print publication a few weeks later, which showed the polling percentage across the country. Just take an Excel map, put in the polling percentages that are published by the Election Commission, fill it in Excel, copy the whole thing, put it into whatever color palette you want, and publish it. And it emerged that there was an entire belt in the country that was not really going out to vote, which was interesting. Now, what this got us to was, on the one hand, a set of tools that enabled people to use these maps, as well as a rough cut working version of the maps that weren't official, but good enough. People could use it and started making stuff on top of that. The next step was to try and give this back to the government and say, look, maybe you should try using these or making yours official. But it's never that simple. We initially tried this with the next set of boundaries, which is the postal code boundaries. And here, the problem was even bigger. We went to the head of the postal college at Mysore, who is the person that's responsible for locating all of the pin codes. And in 2012, we asked him, so can you tell us where exactly the pin codes are? I mean, just the lat longs. Whom should we ask or beg or fall at their feet to get this information? And he said, no one. What do you mean, no one? Well, you see, the way it works is that the zones know where the sorting districts are. The sorting districts know where the post offices are, and the post offices know where the pin codes are. So you could reach out to all of the 25,000 post offices and ask them where the 110,000 pin codes are. They'd kind of know. I said, you've got to be kidding me, right? I said, nope. And there was an ongoing initiative to actually get the locations, just the lat longs of each of these pin codes, not the shapes, the lat longs. It took 3 years, but they did get it. They did get it, and they did publish it online. It's available on data.gov.in, and it's a simple CSV file that has each of these postcodes with their latitudes and longitudes. And it said, yes, now the postal department's got it. Now things are rolling. This was 2015-ish. And now that we have the locations, we need the shapes. The shapes, however, were a bit of a problem, because if we just got the locations, who's going to create the shapes, right? But it wasn't that bad. Yeah, so I don't actually have a slide on it because I'm not entirely sure if I'm allowed to put a slide on this. But here's what happened. The postal college very innovatively and very aggressively started drawing these shapes. They started with one particular city, expanded to one state. They went with the National Mapping Agency, ISRO, the Space Research Organization, which also holds the bulk of the GIS data in the country, and started creating these. After about 8 months of mapping, we reached out to them and said, look, if you have this for at least one district, we can start using it and figure out how this works. They said, sure, yeah, we'll give it to you. 2 weeks later, they came back to us and said, no, we can't give it to you. Why not? Well, ISRO isn't allowing us to download the maps. What do you mean? So they said, see, the deal that we have is that we can put stuff in, but we can't really take stuff out. But it's your stuff, right? Yeah, but we can't get it out. So it's stuck in that limbo. The initiative is going on. We don't have those maps. We don't know when they'll get done. We don't know when they're going to come out. So the next best thing is community driven. Let's just build these maps. Now, the good part is that in the absence of anything official, anything that you create that's unofficial, that's close enough, is good. So we said, let's take the technique of Voronoi tessellation. The way this works is fairly straightforward. What we do, and let me just open the browser here to the right location. I'm sure I have an example, right? So if you have a bunch of points, create a polygon that has all of the regions, all of the points that are closest to a given point. So if I have this as one post office, just that region that is closer to this particular post office than any other region constitutes the bounds of this post office. That's the region. It's good enough. It's a pretty good starting point. And if you happen to have multiple addresses in a certain region, then you can put them all together and say all of these points that are closer to this set of addresses than any other address or zip or pin code, that constitutes the region for that. So the technique is clear. The tool is not that easily available. So it is possible to do this manually with a fair bit of cleaning up and stuff like that in ArcGIS, in QGIS. They're called TSL polygons or Voronoi polygons, depending on which tool you're using. But there are a number of problems. The first is that it's automated, so you can't just upload a CSV file and get it done. Secondly, it's something that you have to get rid of some of the outliers. What if a point is outside the main country's boundary? That has happened. And what if there are gaps in the map? That's happened as well. So we built another tool, and this is called Reshaper. Let me show you how Reshaper works. This is available on GitHub, again, gramna.com/reshaper. I should have the link. Yeah, that's where it is. And it uses GDAL as the base library, and then you just do a pip install of this. So let me give you an example of how we'd applied this in another scenario. So we had the branches of a bank. This is Axis Bank. The data was publicly available. And the data that they had was for each of approximately 2,700 branches, the latitudes and the longitudes, the name of the branch, which cluster, circle, and region it belongs to. And our task was to create a map of the branches. We have the points. We've got to create the shapes, and there's no such thing as an official shape for the region that the branch serves, and they were perfectly happy taking the region defined by the Voronoi polygons as the region. Given this, we said, let's take a base map, such as the 2011 district shapefile of India, which kind of looks like this, and plot a point where a branch resides. Take all of that district that is closer to this particular point than any other point and map that to this branch. Do the same for every single branch. If a district contains more than one branch, allocate them appropriately. If a district does not contain any branch, move it to the nearest one. And what this underlying base map does is gives us bounds that are shaped by the district. It's not purely straight lines like you would have seen in the TSL polygon here. It's not comprised entirely of straight lines. It's shaped and defined by the district boundaries. And if you had lower level maps, such as a sub-district boundary, it could have been shaped by that. So the way this works is fairly straightforward. I should have a command that I've already executed somewhere. Yeah. So I run Reshaper with the underlying shapefile, the list of branches, and the output file that I want to create. I specify what I want to use as an ID. So I could say I want a map of all of the circles or all of the branches or all of the zones. So I'm going to choose circle for now. Pick a column that defines the latitude and longitude and let it run. So it locates the nearest features. It merges the features based on all of the points that it gets into specific groups. It's going to take about 20 more seconds. I'll give it some time. No, actually, I probably don't have too much time. So I'm going to move on and show you the output in a few seconds. No, actually, it's almost done. Give it some time. Okay, a bit more to do. Should have taken a simpler example. Okay, yeah, here we go. And this shapefile that we have breaks up the entire country into the circles as defined by the bank. Now, this does not map to any district, any shape, but you can do it for arbitrary points. And this mechanism of getting to arbitrary points is what took us to the semi-official, or now the only available, pin code shapefile for India. So this now exists, and you can find this on DataMeet, which took us to the last challenge, the toughest of them all, which is the administrative boundaries. The problem here is twofold: ownership and distribution. The organization that created these did this in 2001, and that was as part of the census. The organization is the Survey of India. We tried buying these maps once in 2013, once in 2014, once in 2015, once in 2016. They have a website, they have a contact number where you can actually ask the person for a map. We've tried reaching them, phone, email, personal visit, all kinds of things. Till date, we haven't succeeded in buying these maps. Not once. We don't know of anyone who succeeded. We actually got someone in the Ministry of Civil Aviation who said, look, I find these maps useful, let me try buying it. So we said, okay, great, you're in the government, they're in the government, like buddies, so fine, talk to them, see if you can get it. And with the influence of a minister of the union, he finally came back to me and said, you know what, I've failed. The last that I've gotten to is a document that requires me to basically sign my soul and blood, which says I cannot use this for purpose A, B, C, D, E. It basically leaves out no purpose that I can use it for. I really just cannot get this map. Yeah, so they exist. We know they exist because we've actually seen them visually, but we just don't know anyone who has them other than the Survey of India. So getting these maps is a problem. The other problem is that in 2021, there's going to be an exercise to recreate it. What I've heard from unofficial sources is that the Survey of India does not want to take this up. They like creating topographic maps, not administrative boundaries. That's not their job. But of course, no department ever gives something like this away to anyone else. So they're not going to let anyone else do it either, to the best of my knowledge. So we're stuck. And therefore, this again becomes a community initiative, much larger than the rest. We're almost there. We're getting there. And the biggest support actually that we've received is again from the community. Justin Myers is one of the people that's been working on it. There's a whole bunch of people outside of India who seem to have better sources than the people in India. That is a very interesting thing, but yeah, there it is. And this repository of village shape files, you'll find all of the links on the slide deck. You can just, I'll be sharing the slide deck on the Strata website. This is pretty much the best source that we have for any kind of map that's there in the country. Where are we right now overall? Fact is, there are no official shapefiles. None. These do, however, exist in an unofficial form. And the best way you can get any of these, at least for India, is search for DataMeet maps or Gramnar maps, and that's your next best thing. But over the course of building this, there's a lot of process and a few tools that have been brought in. And the advantage that these tools have is the simplicity that they bring in for regions that do not have existing maps or scenarios where you cannot create a map. Right? If I want to plot the regions that cover the airspaces across an airport, there's no such thing as an official airspace coverage, at least in most places. There's no such thing as an official fuel pump or fuel station boundary. Right. So if you want to create those, the tools for those exist, and they are fairly simple, and you can use those. They are open source too. Also, the community needs help. Any kind of help, anyone with GIS expertise, interest, enthusiasm, contacts, connections, patience, yeah, we could do with any of those. I do wish you happy mapping. Thank you. We may have time for a few questions. And I'm just about out of time, though. Oh, yes, please. Sorry, at the end. Where are the maps being used? Well, let me give you a huge problem area. The data on infrastructure exists at an administrative boundary level. So people know, for example, which district has how many hospitals. What people want to do is tell the elected official who resides at the parliamentary constituency level that in your region, the number of hospitals has increased or decreased. The number of patients has increased or decreased. So we need two shapefiles and the ability to join across those. Neither the shapefile exists nor the ability to join. So this is probably the biggest example of the kind of challenge that this is intended to solve. And it's largely governance related, but is often used by NGOs, by the media, so on. Okay, if there are any further questions, do feel free to reach out through Strata. These slides will be up there. And once again, all the best with the mapping. Thank you.